Detailed look inside the Lucene index format in Lucene. Here you can see a detailed look inside the Lucene's index format. Here .fnm, the fields, stores information about fields here, and .tis, term infos, part of the term dictionary stores term info, and here .frq, frequencies, contains a list of docs which contains each term along with frequency, and .prx, positions, stores position information about where a term occurs in the index. Here in the inverted index, Lucene uses a well-known index structure called inverted index. Quite simply, and probably unsurprisingly, the inverted index is an inside-out arrangement of document in which terms take center stage. Each term refers to documents that contained it. Let's dissect a sample book data index to get a deeper glimpse at the files in the index directory. Regardless of whether you are working with a RAM directory or FS directory or another directory implementation, the internal structure is a group of files. In a RAM directory, the files are virtual and live entirely within RAM. An FS directory literally represents the index of a file system directory as directory. The compound file mode adds an additional twist regarding the files in a directory. When an index writer is set for a compound mode, the files are written to a single .cfs file, which alleviates the common issue of running out of file handles. Our summary glosses over most of the intricacies of data compression used in the actual data representation. This extrapolation is helpful in giving you a feel for structure instead of getting caught up with miniature, which again are detailed on Lucene's website. This figure represents a slice of a sample books index. The slice is a single segment. In this case, we have an optimized index with only single segment. A segment is given in a unique file name prefix _c in this case. Here field names .fnm. The .fnm file contains all the field names used by documents in the associated segment. Each field is flagged to indicate options that were used while indexing. Is it indexed? Does it have a term vector enabled? Does it store norms? Does it have payloads? In order of the field names, the order of the field names in the .fnm file is determined during the indexing and isn't necessarily alphabetical. Each field is assigned a unique integer field number. each field is assigned a unique integer. The field number according to the order in the file, in this file. That field number instead of string name is used in other Lucene files to save space. All terms, this is a term dictionary .tis or .tii file. All terms, tuples of fields, field name and value in a segment are stored in the .tis file. Terms are ordered first alphabetically. According to the UTF-16 Java character by field name and then by the value within the field. Each term entry contains its document frequency. The number of documents that contain this term within the segment. In this figure shows only the sampling of the terms in our index, one or more from each field. Not shown is the .tii file, which is a cross-section of the TIS file designed to be kept in the physical memory for random access to the TIS TIS file. For each term in the TIS file, the the .frf file contains entry for each document contained in the term. Here in our sample index, 2 books have the value JUnit in the content field. Term frequencies. The term frequencies in each document are listed in the .frq file. In our sample index, that for example ant in action document ID 5 has the value JUnit once in the content field. JUnit in action second edition has the value JUnit twice, provided once by the title field and the once by the subject field in this example. Our contents field is the aggregation of title, subject and author. The frequency of a term in a document in a document factors into score calculations and typically boosts a document relevance for higher frequencies. For each document listed in the .frq file, the positions.prx file contains entries for each occurrence of the term within the document. The term positions, the .prx file lists the positions of each term within the document. The position information is used when queries demanded it, such as praise queries and span queries. Position information for tokenized fields comes directly from the token position increment designated during analysis. This file also contains payloads, if any. In this figure shows 3 positions for each occurrence of the term JUnit. The first occurrence is in document 5 in position 9. In the case of documents 5, the field value after analysis is ant action, Apache, Jakarta, ant build, tool, Java, doc development, JUnit, Eric, Hatcher, Steve, Logan. We use the standard analyzer, thus step word, in action, for example, are removed. Document 6, JUnit in action second edition has contents field containing the value JUnit twice, once position 1 and again position 3. Stored fields, when you request that a field to be stored, field.store.ts, it is written into two files, the .fdx file and the .fdt file. The .fdx file contains simple index information which is used to resolve document number to extract position in the .fdt file for the document's stored field. The .fdd file contains the contents of the fields that were stored. Term vectors. The term vectors are stored in three files. The .tvf file is the largest and stores specific terms stored alphabetically and other fields. Other frequencies plus the optional offsets and positions for the terms. The .tvd files list which fields had term vectors for a given document and indices byte offsets into the .tvf file so specific fields can be retrieved. Finally, the .tvx file has index information which resolves the document numbers into the byte positions in the .tvf and tvd files. Norms. The .nrm file contains normalization factors that represent the boost information gathered during indexing. Each document has one byte in this file which encodes the combination of documents boost, that fields boost, and normalization factor based on the overall length of the content that in that field. Deletions. If any deletions have been committed to the index against document content in the segment, there will be a .del file present name _x_n.del, where x is the name of the segment and n is the integer that increments every time new delete are committed. This file contains a bit vector that set for any deleted documents. Now this is the end of my presentation. Thank you very much for watching it.